Good evening. So today we will discuss all assignment. Okay. So first is spectrum. We will discuss. You can see wavelength versus irradiance. UV, visual, infrared. Okay. Sorry. So in UV range, you can see the irradiation is less, but you can see visible in visible range. In visible range, spectrum or irradiance is maximum, you can see. Okay, so if we make our solar cell, which is band gap lie in visible range at maximum irradiance, give maximum current. Okay, if number of photons is higher, then current will be higher. So generally, due to this reason, visible range spectrum is utilized to make solar cell. Also the infrared. Okay, we have discussed the how we can measure solar irradiance. So these are two pyronometer used measure global irradiance and other is pyrohelimeter mounted in solar stack to use method direct normal irradiance. Okay, next we have discussed air mass coefficient. What it is, we can see the shadow length and the object length with respect to the sun give the shadow length. So air mass coefficient defined as 1 upon cosine z equal to air mass coefficient equal to 1 upon cosine z. So cosine z we can calculate here by the triangle rule. Okay, in definition, path length taken by the light through the atmosphere, which is normal to the shortest possible path length when sun is at zenith. Quantify loss of irradiation by dust. So let's see one by one. Air mass 0, 1, air mass 1.5, 2 to 3. So if we calculate 38 air mass AM 38 closer to the horizon, and air mass 1 will be at 0 angle, and for solar cell air mass 1.5 global is used to characterize solar cell efficiency. So this is at theta equal to 48.2 degree. Okay, so the value of the zenith angle at air mass AM 1. Please choose your answer. AM equal to 1, or 1 upon cosine z. So please find the cos theta 1 by 1 equal to 1. What is the value of theta z equal to cos inverse 1? This will be 0 degree. Cos 0, you know, cos 0 equal to 1. Okay, so this is the procedure. You can calculate the air mass coefficient. If the given index is given, then you can easily calculate the theta. Okay, here is the definition. Air mass coefficient defined as a direct optical path through the Earth atmosphere expressed as a ratio relative to the path length vertically upward, that is the zenith. Okay, so zenith with respect to when Earth atmosphere above is air mass 0, but on the Earth air mass coefficient is will be 1. So this is the definition we have. The spectrum outside the atmosphere approximate by 5800 Kelvin black body is referred as AM0. Okay, 0 atmosphere. So this is useful for space application. Okay. So AM also we can define as P by P naught equal to ZZ. What is P by P naught? Let's say sun is, we have two positions, different time. P by P naught. Okay. Ratio relative to the path length vertically upward. Next question, calculate the visible range for the available energy range for visible solar spectrum. So how can in visible range, how can you calculate the energy range? We know the formula, and lambda in nanometer, that energy will be lie in electron volt. So please use this relation and put the, let's say put the, let's say put 400 nanometer, which is lie in the visible range, and other you can 700. Please put this value and see the option you can find. Visible, according to the wavelength of visible spectrum, give the energy. This relation, by this relation, 1.6 to 3 electron volt. Or reverse, you can also find. If let's say question, you have a energy equal to 3 electron volt, please find the wavelength. 3 electron volt energy photons, where is light? Invisible, UV or infrared? Question will be asked like that. So you can also find 1240 divided by 3 electron volt. This is lambda will be lie in nanometer. And 1240 around like that. Okay, so light this side in visible range. So this is easy, I think. Elevation or altitude angle. Which of the following is angle? We will discuss. Let's discuss the angles here. Which of the following is angle between the sun ray and its project on the horizontal plane? So altitude angle. Which of the following is angle between the sun ray and its projection on horizontal plane? This is, and this, sorry, this angle is altitude or elevation. Or if horizontal to the sun ray, known as zenith angle. You can see also the other angle, latitude or longitude angle. Lambda is longitude, phi is latitude. Okay, other is azimuth angle. Angle made in the horizontal plane between the northern and south line to the projection of the sun ray on the horizontal plane. You can see here. This is sun, so this is projection, and find the angle between northern and south. So this is known as azimuth angle, and this is range is minus 182 plus 180. Next is we have already discussed in assignment first, declination angle. Declination angle of the sun is angle between the equator and the line drawn from the center of the earth. So this is, and we have to sun. This is the declination angle. Equator, this is. So formula for this is delta equal to 23.45 sine 365 365 plus n plus 284. So let's discuss on the question. The approximate value solar declination angle on March 30th, 2023 is sorry. How can you calculate? Let's see. This is the formula. This is the number of day starting from January. So Jan, February, March. Number of days 89. Put this number of 89 here, or you can use other similar formula n minus 80. Also you can replace. Give the same result. So delta will be 3.618. Okay. So use this formula, you can easily calculate if number of you can calculate. Other question, declination on summer solstice is so answer will be B. Summer solstice. Please find the n, then put, then check your answer. Okay. Next, the value of the hour angle at 3 p.m. local solar time. So this is the definition and formula. Hour angle 15 degree LST minus 12. So LST is 3 p.m. means 15. Put the LST in this equation. You can hour angle theta 0 solar and 15 is why, because the earth rotate per hour is 15 degree. Equation of time, let's discuss. For a local in Goa, this is given 13,2000. So answer will be C. How? Let's see. This is the formula. Equation of time 9.87 sine 2b, and b is defined as 360 divided by 365 and minus 81, which is inside in the, you can, we have already seen declination angle. We can also use this is the okay. So is the same b angle. Put this angle here b, and number of, calculate the number of days, and and n is given, sorry, 150. Put the 150, you can calculate it b and 2b. Then equation of time, put the b and 2b, you will get the answer. Okay, maximum day length. So maximum day length is 2 by 15 cos inverse 10 delta and phi. So here is the given, phi is 26.45 and delta we have calculated for this question in previous question, so 3.62. Put this value in this equation, you can see S max 2 by 15 cos inverse delta and phi, then you will easily get the answer 11.6 7 7 6 sorry hours, or convert into minutes, hour and minutes. So please remember formulas and procedure, how we can calculate, and what is theta, delta, phi, lambda. Next question, I think we have discussed this. Let's see. Intrinsic semiconductor, our theta and m definition are in is completed. Now move on semiconductor part. Okay, so semiconductor with band gap is given 1.5 eV. What the position of EL at 300 Kelvin if mass of hole is 6 times of mass of electron. So this is the formula. AC by 2 3 by 4 kT mass of hole, effective mass of hole, effective mass of electron with respect. So put this value. kT at 300 Kelvin will be 0.0258, or you can approximate 0.026 electron volt. Okay, and band gap is given and m is given. Put this value in this equation, all values, you will get this step, and after simplification you will get the Fermi level 0.78 eV. Okay, next question, nature of variation of momentum p, wave vector k. Okay, so momentum and k linear, h cut k, this is the formula. So this is the constant, so this is linear, but energy, what is the relation between energy and momentum, sorry, wave vector? So hyperbolic or parabolic? What is the question? This K and E. You know what is this question in mathematics? Parabolic. So this is the relation. I think we have discussed. What will be the effective mass of electron in the radius of curvature increase 2 times? Then 2 times. So effective mass is directly proportional to the curvature, radius of curvature. Next, in an intrinsic semiconductor such as a silicon, mobility of the electron conduction band is greater than the mobility of the hole in the valence band due to higher effective mass of hole in compared to electron. So effective mass of hole is higher, will be high as compared to electron. This is the reason, effective mass of hole is higher. than the electron, so movability is inversely proportional to. Let's see next question. In indirect band gap semiconductor, transition between conduction band and valence band result in indirect. Please choose your answer. What is your answer? Yes, please. Both. Okay. So direct delta K should be 0. Momentum should not be changed. Only energy will change. Something not equal to 0. Indirect. But this is direct for indirect momentum also change and energy also changes. So both. You're, you're right. Next question. What will be the probability of finding electron in a state at Ec plus 2 kT when the Fermi level EF is positioned at the conduction level? So please use this formula. Probability of finding equal to 1 upon E exponential E minus EF upon kT, and EF is position at conduction level, so EF equal to EC, and finding electron state equal to also given E plus 2 kT. Okay, so this is given, this is also given. Put this value in this equation, you will get the probability 0.12%. In percent 12%. And this is finding probability and occupied probability of finding of electron. Not finding, so you can 1 minus p use. What will be the answer? Not finding the electron in this state. In percentage. Tell me. 1 minus p. Use this. Finding and unfinding sum should be 1. Probability should be 1. Either find, either not find. So what is your answer? Not finding the electron in this state given. Hundred minus 12 in percentage term. 88 percentage. Not finding. Clear? If you have any doubt, you can ask. Clear to you? Please respond. If you have any doubt, you can let me know. So, can I move for next question? Okay. So next question based on also probability filling or empty state. So where would be the Fermi level located when the probability of state filling at what is E plus kt is equal to 1/4 time of probability of state is empty at this state. So E is given for filled and empty. So you formula for filled, you know, probability, and empty 1 minus, you can put this 1 minus filled, and this is given condition filled equal to 1/4 time is empty. So use this relation and these formulas. This is given condition. Solve these equations is also given for filled E plus kt, for empty is also E plus kt, same. So if you solve, you will get this answer. EC Fermi level equal to EC plus kt minus kt ln 4 is this relation, sorry, this condition. When we apply this condition and we know the formula, so this is simple, nothing complicated. Next question, what is this? What is a given? What will be the whole concentration in pieces of silicon sample maintained at 300 Kelvin with an electron concentration? Electron concentration is given under equilibrium condition, and intrinsic condition also given. P you have to find, so use Ni square equal to N into P, and you will get easily answer. Next question. We have already discussed, but I am again repeat. If you have any doubt, you can ask. So this question is intrinsic carrier concentration of semiconductor increase from 10 to the power 10 per centimeter cube to 10 to the power 14 per centimeter cube upon increasing the temperature from 300 Kelvin to T1. The band gap momentarily is given. So what? T1 is, what is the T1? This is the question. So this is the formula. In red you can see NCNV half exponential Eg by 2 kt. So this is constant for acceptor. Let's say for first case semiconductor increase concentration. This is, let's say, Na, this is Nb. For Na and Nb, and divide this expression and put the value of Na and Nb, you will get this expression up to here. After solving, you will get the temperature. So remember this formula, nothing else. If first time is Na to increase Nb, so use for Na this expression, and then Nb also the same expression, and divide both and put the value, then solve. Okay. Next question. The electron mobility of semiconductor is 600 centimeter square volt per second. Then the carrier scattering time is estimated as, so mobility equal to q scattering time and mass of the electron. So mobility is given, we know the charge q, and put this value, you can easily get this relation give to you tau scattering time. We have mobility, charge, and mass. So after calculate we will get this 3.4 10 to the power minus 13 centimeter. Next question, based on resistivity. The resistivity of intrinsic semiconductor is 4.5 ohm per meter at 239 Kelvin, 223 Kelvin. Now it is increased the temperature up to 305 Kelvin, then resistivity is 2 ohm per meter. Sorry. The energy band gap in electron volt corresponding to the wavelength semiconductor is. So use this relation. Uh, so use this relation, you can easily find the band gap. T1 is given, T2 is given, rho 1 is given, rho 2 is given. Put this value in this equation. After simplification, you will get the band gap material. So this is the formula. Next, also the resistivity, conductivity and resistivity. We know the conductivity. Resistivity is 1 upon conductivity, and for conductivity we have a formula: charge carriers, density, concentration, electronic charge, and mobility sum. So carrier concentration is given, mobility also given. We have to find the resistivity. So put this given value in this equation, then simplify, you will get the resistivity. Ohm per ohm meter. So remember these formulas, then put the given value, then simplify, you will get the answer. Next question, what is question? Answer is C, but let's see what is question. At very high temperature, the position of Fermi level in p-type semiconductor shift to. At very high temperature, position of Fermi level in p-type semiconductor is working as like an intrinsic semiconductor. Okay, the electron drift current in a semiconductor due to. We know drift. Why is it drift? extra field should be there is a external field which is your electric field. So in assignment we have discussed these questions, but I am repeating. If you have any doubt, let me know. Concentration gradient give the diffusion current, but electric field, let's say we have plus and minus. So electric field positive to negative. If electron has there, then feel the force due to the Coulombic force and drift move from opposite to the field. Electron has negative charge. So this is if moment of charge carriage is happen, then current will be there. This current is known as drift current, which is due to the electric field. Okay. Also the question at which the position band gap in the shallow trap reside in p-type semiconductor. P sides closer to the conduction band, sorry, valence band, p-type. Fermi level near to the valence band. Also the shallow trap near should be the valence band. In n-time will lie closer to the conduction band for n-type. Okay. Next question. Forbidden energy gap of silicon material measure EK diagram is the difference between energy band gap of any material in EK diagram. Difference between global we have to find global minima here and global maxima here. Not much like that. 1 minute. Let's say you have two minimas and one maxima like that. So this is global maxima and this is global minima. So difference between these energy levels known as forbidden energy gap. Global minimum of the conduction band and global maximum of the valence band. Okay. Here you can see forbidden energy gap, which is known as band gap of the material, indirect or direct. Which of the following reason for the band bending observed in the semiconductor material? Why band bending? At the depletion region, there is immobile charge concentration, which is give the electric field at this interface, and that's why this is band bending will be happen. Okay. Equal to minus dV, derivative of potential. And next is Which of the following represent the dependence of charge density on the electric field in the depletion region? Charge density. So charge density rho d by dx, sigma rho or delta. Sigma for linear, areal is sigma. For volume, we'll use charge density rho. Next question, please see. You have to use draft velocity equal to mobility time the electric field. So what is given? When electric field of intensity, electric field is given. 12 volt per centimeter is applied across the semiconductor at a certain temperature has the drift velocity of the fluid. Drift Vd is also given. The mobility we have to find. So use this simple relation. Vd equal to mu time E is given, Vd is given. So put this value in the SI unit, or you want to change in centimeter, also change the both side. So you have to check the units also. Then put the values in this equation. First you will get the movability. Simple. Next, semiconductor material for the good solar cell. Which type of recombination should be happen? You know. Okay. So semiconductor material for the good solar cell. Which type of recombination should be? Band-to-band transition. Why? Sorry, my slide is lagging. I want to only the air-to-air transition. Defects free. Material should be defects free. If the defect is there, then the recombination trafficking of electron hole pair will be there. So our number of electron hole pair will be less. So performance of solar cell will be less. So that's why our material should be defects free. So only band-to-band recombination is needed for good solar cell. Okay. Which of the following statement is true? So we know direct band gap material has larger absorption coefficient. Absorbing in direct band gap semiconductor involve only photons. Momentums are changing. Indirect band gap material exhibit lower absorption coefficient. Also we know as compared to direct band gap semiconductor. Absorption in indirect band gap involve only photon absorption or emission. Indirect only phonon absorption and emission. Not only phonon but also photons. Okay, so you know the mechanism of direct and indirect band gap, how to charge carrier is cause conduction band to valence band. Next question is absorption coefficient in case of direct band gap semiconductor. So this is the formula. B star is the constant h nu minus h nu Ag by to the power 3 by 2. Based on this, we have calculated the absorption coefficient. Photon energy given 1.6 and 1 electron volt. What is the and the band gap is given 1.4. If the photon has less the energy with respect to the band gap, then there will no absorption. In B case should be 0. First case you can calculate. Put a value in this equation. Next question. When there is a multiple recombination mechanism, how can we determine the effective minority charge carrier lifetime? All the processes. So recombination is inversely proportional to the generation or lifetime. So use this relation. We know the RT total, band to band, RG center, exciton, OJ, cello. All processes are involved. So use the remove the constant proton. Let's assume a constant and put this value in this equation. Total R recombination RSH ROJ. So will be total will be lie. Okay. So this will be the total lifetime, multiple lifetime charge carrier recombination. So this is effective to effective. Next question based on the relation between the minority charge carrier lifetime diffusion length in p-type semiconductor. So carrier lifetime diffusion length equal to diffusion length equal to diffusion coefficient and the lifetime of the charge carrier. Sorry. So we know the Einstein coefficient Kt by E T by mu. For this question, we want to D relation. This is the just relation. So relation is this, but question next is calculate the diffusion coefficient of the electron at 100 Kelvin in p n-types isotope with the mobility of electron is given this and as a atom per centimeter cube dope. So Kt by E here is diffusion coefficient we can easily calculate. If you want to calculate the diffusion length, then use this relation p type or n type, replace p by or n. So remember the formula and what is the significance of this formula, how we can use, then you can easily get the answer. So this is the derivation explanation. Question: cellular trap in n-type semiconductor resided with the position. We have already discussed, I think, near to the conduction band. Question: RG center mid the between the conduction and valence band, closer to the mid capacitors. Okay. What is next question? N-type semiconductor as mobility, sorry, resistivity is given. Electron and hole mobility also given. Donor concentration of the semiconductor. So use this formula, convert the ND, put the values, you will get the donor concentration. The absorption of photon energy semiconductor material with band gap is given. Take place only the when will be the processes happen. Incident photon, let's say photon energy h nu should be greater than or equal to the band gap. Okay, then only the absorb the material, otherwise transparent for of photon. If energy has a less of the photon with respect to the material. Upon applying the forward bias PN junction, what will happen? Forward PN junction. Please choose your answer. Please your answer. Yes, please. Upon applying forward bias, what will happen? And C. This is the correct answer. Please see. If you have doubt, please ask. Forward bias. P type connected to the positive terminal and N type connected to the negative. So hole diffuse from P side to N side. And electron, the electron diffuse current from N side to P side. Majority charge carrier move. For N bias PN junction diode at a thermal equilibrium, which of the following statement is true? At equilibrium, unbiased PN junction, thermal equilibrium. So current diffusion and drift current will be at a equilibrium for P or N should be 0, for P should be 0. Diffusion and drift current are equal at equilibrium. Okay, otherwise, let's say in beginning diffusion will dominate it, then drift after the diffusion. Charge carrier are depletion region at form, then electric field is there, then drift current will be there, and then drift color current is increasing and diffusion current is and increasing. Sorry, diffusion will, let's say, same, and drift current is increasing and equal to the diffusion current, and they are in opposite in sign, they are opposed to each other, then will be the there will be the equilibrium at some moment. Okay, initially diffusion only will happen, then after some time, due to the concentration, sorry, due to the charge, negative and positive charging, let's say p-type and n-type, holes is moving an electron initially. So due to the concentration gradient, only diffusion current initially. But what happened? Let's say hole is moved, then positive charges leave to negative. Initially, let's say P is neutral, but one hole is Q to the n-type. Then what will happen? Positive is given, so negative charge will be there. Negative, and this side is positive. Electron is dominant, then positive charges. So electric field is formed. There will then immobile charge carrier near to the interface is formed. Then electric field is there. So this electric field give the drift current and balance to each other, then called the equilibrium. Okay, so according to these option, A, C and D the correct answer. Next question, I think we have discussed, but let's discuss again. Consider an unbiased p-n junction diode in thermal equilibrium under dark. When forward bias voltage is applied, then what happened to the Fermi level of the n side? The Fermi level of p side intrinsic level is, so Fermi level intrinsic is goes up to the conduction level, also the higher Fermi level of n type to the p type. Which of the following is valid p-n junction diode under unbiased dark conditions? So option either. Which of the following valid p-n junction diode in unbiased dark condition? Unbiased and dark condition. So there will be no generation and depletion take place in the depletion region. When a reverse bias is applied in p-n junction diode, it will be raise the potential barrier to the transport. Okay, this is reverse bias. Forward, lower. the potential. If asked forward, then you will potential barrier is goes down and depletion width is less reduce. But in reverse saturation, depletion width is goes higher. For forward PN junction diode, depletion region width is decrease. Mm, and built-in potential is decrease also. Electric field in the bulk region PN junction under bias is 0 only at the interface, sorry, in the depletion region. Charge carrier density in the p side and of the PN junction, p side electron is coming, so number of electron is higher, electron charge is minus e. So due to this minus q into acceptor density. Which of the following statement is correct regarding the PN junction diode under dark condition? So electric field in the bulk is 0 but not 0 in the depletion region. Free charge carrier density depletion region is 0. Current in bulk region is determined by the diffusion of minute charge carrier. Next question, you have to calculate built-in potential. So formula is VBI KT by QLN N acceptor Turner and intrinsic concentration square. So use this formula you have given ND, Na and Ni. Put these value and at 300 Kelvin KT by Q will be 0.2026 volt. Put these value in this equation, you will get the VBI built-in potential 0.479 volt. Okay. So which of the following Einstein relation electron non-degenerate non-uniform doped semiconductor? So relation always be n-type KT by Q. So this is the Einstein relation. Diffusion by mobility KT by Q. Sorry. So forward bias condition is given. Applied bias is 0.2 volt. Given doping concentration P and N side diode is 10 to the power 15%. Intrinsic carrier concentration is 10 to the power 10. Junction potential. So junction potential, built-in potential minus V acceptor. If forward reverse is asked, V junction VBI plus applied potential for reverse. This is for forward. Okay, so value is given, you can put and solve this equation. You will get the correct answer. Next question, diffusion coefficient. Electron hole are given and the carrier lifetime are also given. What is the ratio of diffusion lengths of the electron holes semiconductor? Coefficient are given and lifetime of charge carrier are also given. So use the formula of diffusion coefficient length. Let's say n equal to diffusion length of n electron square root of diffusion coefficient of electron and lifetime of electrons carry. Similarly for holes, take the ratio, you will get the ratio of the diffusion length, or you will get individually if you solve this. So question will also ask like that, calculate the diffusion length only for N or for P. Here is the ratio is asked. Consider a P silicon and silicon having AF and as their Fermi level. Which of the following true? Thermal equilibrium when both are joined together. So PN junction is formed, then only one Fermi level is there inside the material. Okay, so according to this, C is answer. Next question, you have to find the depletion width. So use this formula and other things are given. Concentration of electron holes, acceptor donor, built-in potential, applied forward is given. Okay, use these given parameters in this formula, depletion width. Okay, you will get the value of depletion width. So remember this formula, built-in potential VBI is calculate, then forward condition. So this is simple, I think, but you have to remember formula and how to apply the formula. Next question, which of the following represent the ideal diode equation for PN junction diode? So you should know the diode equation I equal to I naught exponential QA by KT minus 1. PN junction diode under illumination at short circuit condition. Sorry. Minority charge carrier move across the depletion rate due to the drift. Next question. Which of the following characteristics for illuminated PN junction diode? So recombination current in the diode balance the photocurrent at open circuit voltage. Okay. Which of the following strategy used to improve the quantum efficiency? So surface passivation and using anti-reflection and texturing. Okay. Which following parameter doesn't affect the quantum efficiency of the photon device? Yes, please answer. Choose your options if you know. Give me 1 minute. Think about this. Please choose your answer. Yes, please, your answer. So, doesn't affect means only the applied electric bias is not affected, but absorption coefficient, thickness, and surface quality all are affected. Okay, so this is only the not quantum doesn't affect the quantum efficiency. This is affect. So in lecture also is given. Following is are correct for the designing operation of the efficient photovoltaic device. Please answer if you know. Sorry. So please see minimum accumulation rates throughout the device. Maximization of absorption if energy is greater than the band gap, and low surface accumulation from the cell surface. So losses should be less. Only the condition. Which of the following device characteristics and determine JV curve, illumination, PN junction, solar photovoltaic device? Yes, please. This is called JC, VOC. Somewhere else is the maximum power point. So maximum power is less than or equal to maybe at the VOC, and I maximum also less than or equal to. Sorry, this is VM equal to Jm. And at maximum power point, if we get the partial derivative of power with respect to voltage should be 0. I into V give you power. If we take partial derivative with respect to should be 0 at maximum power point. Next question. Open circuit condition in PN junction photovoltaic device is correctly represented as open circuit condition PN junction photovoltaic device. Open circuit VOC. So here is current is 0, but voltage is not 0. Okay. Next, current density PN junction under the illumination is given by this. So at open circuit voltage condition, ideal PN junction above expression modify as. So we know open circuit condition, current should be 0, voltage should not be 0. So this is the condition. use this condition and solve this given expression for this condition. You will get your answer. So VOC, and this is the also condition. Next, let's move for next question. Consider highly doped P-N silicon diode with acceptor and donor concentrations are given respectively. The hole diffusion coefficient and N site is given. Lifetime also given. When the active area of the device is 10 to the power minus 4 centimeters square, reverse saturation current is given. Sorry, is asking a. So this is the formula for reverse saturation current I naught equal to QAD, diffusion coefficients and diffusion length and concentration. So first calculate the Pn and diffusion length. Put this value in this equation, then you will able to find the saturation current. Okay. Next question. PN junction solder cell has VOC, JSC are given respectively. Second solder cell of the same area, VOC and JSC are given. Assuming both cells obey the ideal diode equation, what are the values of VOC and JSC when the two cells are connected in parallel? Okay, so we know the ideal diode equation. They are connected in parallel, so voltage are equal and current will added. This is the condition. So apply this condition according to the given. Current will be 36 milliamp per centimeter square and voltage at open circuit we know the current will be 0. Here we can calculate the VOC. So applying this condition, VOC will be 0.52 volt across both cell. Consider PN junction diode area is given and illuminated 100 milliwatt per centimeter square. Given short circuit condition 25 milliamp percent, open circuit voltage 1 volt, maximum power 40 milliwatt, fill factor is so 80. You can use this formula P maximum upon VOC into JSC. Next similar question, but here is efficiency is asking. So first you can find the fill factor. Efficiency you can use this formula. Or efficiency you can also calculate P output upon P input. Output is 30 milliwatt per centimeter square. So you have to multiply 1 centimeter also 1 centimeter square around 30%. Okay, this is also near to 30. So this is also the trick or formula. Next question. Extract power from a solar cell can be maximized by. How can you maximize the power? resistance. So shunt series resistance should be zero and shunt resistance should be infinite. You know the IV curve. This is this line give to the shunt resistance, and this is give to series this side. So ideal were should be like rectangular, but deviate so then this should be parallel to the horizontal, but looks like that. So shunt should be inverse of the slope, give to you the resistance. So shunt resistance should be infinite and series should be zero. Yes, next question. Solar cell has a band gap Ag1, Ag2, Ag1 is greater than Ag2 are illuminated by one sun radiation. Which of the following expected to the true concentration only optical losses? Yes, please answer this question. What is your answer? So check your answer. Correct answer is A and D. Well, VOC is same to as band gap, but current density is opposite. You can see in chart. As the band gap is goes to higher, 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 current density goes to low, low, low. Which of the following is correct for the ideal IV curve solar device? Yes, please see this question. So, inverse of the IV curve, this is for shunt, this is for series. So, series should be zeros and should be infinite. The correct sequence for generation of electricity in the solar cell is first is absorption, creation of exciton, excitation, dissociation, diffusion of charge carrier to electrode, and collection charge carrier. Next question. Which of the following are correct multicrystalline silicon solar cell? Sorry, multicrystalline large number of grain and grain size is smaller. Silicon nitride coating on the emitter in polycrystalline silicon solar cell is done to reduce the reflection losses. Next question, show circuit current 10 milliampere 1 am 1.5 illuminated. The reverse saturation current is given. Open circuit voltage is neglected. Any internal resistance cell would be. So VOC, you can get, this is the formula, VOC KT by equivalent I by I naught plus 1. So use this relation. After simplification, you will get the VOC. Next is typical absorber layer of silicon solar cell is 50% of the light with the wavelength lambda is given. From the assuming that the absorption coefficient for infrared light is alpha is 10 centimeter per centimeter, the absorption approximate thickness of the absorber layer. So use this relation I equal to I naught exponential minus alpha kt. Alpha is absorption coefficient, T is thickness of the material. So 50% according to the thickness is 693.14 micrometer. Yes, which of the technique and associate role are correct among the following when the improve the device efficiency is concerned? Yes, please choose your answer. Your answer, please. So see the answer. Texturing increase the light trapping and surface specification lower the surface recommendation. Use anti-reflecting coating decrease the reflection loss. So I want to increase the light light inside the material and reduce the losses. This is the strategy here. Calculate the mobility of the electron having mean free time at 300 Kelvin, 0.1 picosecond. Also calculate mean free path. So this is given. You can use this formula, and we know the VTS. We know the formula 3 by kt equal to half mv square. Use this velocity and you can easily get the mobility, but lifetime is given, Vt is used, then you can also calculate the diffusion mean free length. Sorry. Okay. So according to this formula, this is the mean free length. Which of the following type exhibit the lowest carrier mobility? Amorphous silicon, we know. Which of is commonly impurity in metallurgical silicon grade? Aluminum or calcium? Okay. Next, the intermixing of cadmium sulfide and cadmium telluride layer in cadmium telluride solar cell leads to. Please please choose your options. Answer. So answer is decrease in quantum efficiency at lower wavelengths. You can see the response. Blue response due to the front surface recombination, and red response due to the rear surface recombination. So explanation, you can see intermixing cadmium sulfide and terminal leads to the higher band gap. Okay, shorter wavelengths this side. Next question. P-type character gallium arsenide can be enhanced by. Yes, please choose your option. Okay, A, thank you. Yeah, A is the correct. For N-type, you can see this is the ACSISN, and P-type ZNMGC. Which of can be window layer in gallium arsenide solar cell? Window layer. We have already discussed these questions, so please give me answer. So answer is in Al and Ni with gallium arsenide can be used as a window layer. CD's cadmium chloride treatment. Cadmium chloride solar cell result in larger grain size and reduced defect density. N-type characteristic cadmium chloride solar cell can be improved. So doping we have already seen indium and cadmium interstitial. This is the explanation. Okay, doping in indium. Indium as a donor impurity cadmium chloride, meaning its donate free electron, enhancing N-type characteristics. Also, the extra cadmium atom by interstitial act as a donor, increase the N-type conductivity. Next question. Following properties of perovskite materials are beneficial for their use in solar cell. Perovskite material. Yes, please choose your own answer. According to your answer, please, what option? So answer is high absorption coefficient, longer charge carrier diffusion. So perovskite has these super high absorption coefficient, high charge carrier mobility, high diffusion line, carrier lifetime also high, tunable band gap, solution vacuum fabrication, low cost. This gives to the superpower conversion efficiency, but problem is lifetime is stable. Next question, region of using soda lime glass as a substrate in the fabrication copper, indium, gallium, selenide, solar cell is yes, please. Soda lime glass. So answer is sodium helps to surface passivation and sodium improve the film texture. You can see surface passivation. Which of the following is are the critical issue in dye synthesized solar cell, DSCC solar cell? Last time we have discussed this question. Please answer. Okay, you are right. Liquid lyse is the critical issue in electrolyte degradation. Electrolyte and liquid lye. The starting source of sulfur for the window layer deposition of copper, gallium, and selenide solar cell is so this is the Kelvin. You can see sources SCNH2 cooled twice. Which of the following is used as a dopant in polypyrrole based organic solar cell? Yes, please, your answer. So answer is FeCl3. If polyethylene, then as polyethylene, then we as a dopant use SO3 FCF3 minus. Photoelectrode used in dye synthesized solar cell is R. D. Okay. Also the C. Nanostructure TiO2 and ZNO. The band gap of copper indium selenide can be tuned by. Yes, please answer. Okay. Indian-Gilliam ratio. Beta character of the copper Indian-Gilliam cylinder is attributed to the sorry. Okay, you are right. Copper vacancy. The dopant added as a polythiophene to make it conductive. We have already seen answer. Please choose the correct option. Okay, D. Yes. So I think all that assignment is discussed. So thanks for your kind attention and best of luck for your exam and the best. Yes, you don't have a link. Let me give to you 1 minute. Give me 1 minute. I will be provide. Yeah, this is the link for all documents. YouTube link, also the PPT link. Okay, you can find here. And yeah, question like similar the assignment. So if you have any doubt, you can also email me. My email, let me show you. This is the Harishankar underscore s at the rate ph.iitr.ac.in. Okay, so this is my email address. You can also email me if you have any doubt. And in chat box, this is the link regarding the whole session recording, also the PPT. Please solve all the assignments and see these like recordings and learn the basic and formulas and try to solve more questions. Question will be similar like that assignment. So thanks to all of you and best of luck. Okay, bye bye.